Hello, welcome again. We are solving some questions of production of material or manufacturing science. The topic is metal cutting. Question number 34 is a C50 steel flat surface of dimensions 100 mm into 250 mm is to be produced on a horizontal axis milling machine. An HSS slab mill with a 100 mm diameter and 150 mm width is to be used for the purpose. The milling cutter has 8 teeth. The entire stroke can be removed in one depth of 2 mm. Take V is equal to 20 meter per minute, F is equal to 0.13 mm per tooth. So answer options are A 2.633 minute, option B option B 2.516 minute, option C 2.114 minute, and option D 1.487 minutes. Okay. So first of all, this is your mini cutter, and this is approaching this slab, and this is the initial point of the slab or point of contact of milling cutter and slab, and this is a this is a this d depth, and this is the radius of milling cutter. So from this radius, this dimension, from this radius or d by 2, and this depth we calculate OB. So OB is your d by 2 minus d, and this is your d by 2. So AB can be calculated as uh, AB can be calculated as d by 2 square minus d by 2 minus d whole square, or it will be d minus d by d. So here in this, in the milling, the approach is uh, small d bracket capital D minus d root. Okay. Similarly, over travel will be same. Okay. So now we'll solve the question, and here given data are number of teeth Z is equal to 8, diameter is 8 100 mm, depth of cut is 2 mm, and cutting speed is 20 meter per minute. F is 0.13 mm per tooth, and approach can be calculated by that we have seen root d capital D minus d, that is uh, 2 into 100 m minus 2, that is that will be 40 mm. Okay. And spindle rpm or spindle speed can be calculated as speed is given as 20,000 meter per minute. Okay, that is 20,000, and pi and diameter of the cutter is given as 100 mm. So rpm of the spindle will be 63 divided by pi d. Okay, dividing speed by pi d. So rpm will be 63.66, or ck we can say it is 65 revolution per minute. Okay. So now the total distance, as we have to perform the cutting operation in one pass only. So we'll take so we have to remove the cutter also. Okay. And for the removal of the cutter, we have to add this extra dimension also. That is, we have to remove when this cutter reaches here. So a point will so over travel will be this for complete machining. Over travel will be this C point should be here. Okay, and A is here, and only single pass has to be performed. So we have to remove this cutter also. So the cutter has to travel this much distance also. Okay. So, so now the total distance travel will be by the cutter will be L length approach, and if A point is here, then over travel, and for complete removal we will add radius also. Okay. So total distance travel will be length of workpiece approach and over travel plus diameter of cutter by 2 or radius. Okay, so that comes out as over travel and approach are same. So total distance travel is 178 mm, and time for machining is equal to total distance traveled by speed per minute. Okay, so that is 178 mm, and feed per tooth is given, that is 0.13, and number of tooth are 8, and rpm is 65. So that is your so if we divide total distance by feet per minute, so we get that 2.633 minute answer. So answer is your A. If we use that same data, that is 63.66, then we calculate this answer as, let us calculate 150 plus 28 divided by 0.13 divided by 8 divided by 63.66. So that will be 2.688. So that hardly makes a difference. So because other options are far away, so answer is option A.